The last practice area in this category that we're going to look at is component development. And the basic problem for component development in a software product line context is making sure that the components have the requisite support for the variability that was identified in the product line architecture. The idea of components as a unit of composition resonates nicely with the concept of a software product line, modulo the caveat that you need the guidance of a software architecture, that you can't rely just on component-based development alone. So when you have identified the architecture for how to wire all these components together, and you've inserted the appropriate points of variation in the architecture, then part of the job of conforming to the architecture means that the components have to support the variation in the architecture by using component level variation mechanisms. And there is a representative sample of variation mechanisms on these two slides. I'm not going to go through these in any great detail. There is a reference for these. In fact, this list comes from a paper that was done by the people at the Fraunhofer IESE, where they looked at the range of variation mechanisms in component-based development and looked at the suitability of a subset of these for different purposes. I don't think it was specifically aimed at examining them in a product line context, but at least it looked at what's an appropriate use of this mechanism versus that mechanism. And you'll see in the list here that there's a range of mechanisms of varying sophistication, just as we saw in the list for architecture. So things like static libraries or dynamic class loading in Java. There are some techniques where, as Straustrup, I think it was, put it, like if-defs that will allow you to shoot yourself in the foot. And then there are others like dynamic class loading or reflection in Java that will allow you to blow off your whole leg. So your product line architect needs to be aware of the range of variation mechanisms that can support the points of variation in the architecture. And the architect will probably have to make some decisions about restricting the range of variation mechanisms. You don't want to give everybody a free-for-all in implementing the variation. And in software architecture, less is more. What looks like a locally optimal way to do things may not necessarily be optimal for the entire product line. The other thing that you need to consider when you are looking at variation mechanisms and component implementation is the skill level of the component developers. For example, it may be an organizational strategy to create sophisticated component assembly approaches at the core asset level so that lower skilled programmers can assemble components pretty readily. If that's your approach and somehow that gets miscommunicated and the architects end up creating a very complex variation mechanism that's implemented in one of these much more sophisticated variation schemes that's beyond the competence level of your programmers in component development, then you are potentially wrecking the business prospects for your software product line. So there are many considerations that come into play in a product line and in a production strategy and in the kinds of variation mechanisms that you would choose to support the production strategy. And as I said, you can get a lot more information about these different kinds of variation mechanisms in that paper. There's also a chapter in Ivar Jakobsen's book from, it's going back a few years now, on the reuse-driven software engineering business, where he also looks at the different kinds of component-level variation mechanisms. But the risk in all of this, the biggest one, is that the components that you produce are not suitable for reuse across the product line. And in fact, the worst thing you can do in core asset development is hand off buggy software components to product development. You need to make sure that what gets handed off from core asset development to product development is of high quality from the get-go. Otherwise, particularly if you're structured into different units, the core asset team gets a reputation of not being trustworthy, and the tendency will be for product development to go their own way with all of the potential clone and own implications there. So if you have a situation where product development is bypassing the core asset base in the interests of expediency or quality, you have to ask yourself, you as the product manager, core asset manager, or product line manager, whoever is tasked with supervising this interrelationship among core asset developers and product developers, you have to ask yourselves, what's going wrong here? How can I correct this? How did this situation even arise that we have this mismatch between these parts of the organization? You also run into the problem of, if you're not handing off quality components to product development, then product development is going to be slowed down and you're not going to get your products out on a predictable delivery cycle, which in turn leads to low customer satisfaction and low organizational morale, because all the promises of product lines that were made at the beginning are not being realized. So you better make sure that the people who create the components that are going to be core assets know what they're doing. And ending up with poor quality components can result from, first of all, your component development effort hasn't been really thought through, in the sense that you haven't looked at, here's the set of components that we can readily create in-house. Here's another set of components that we don't need to waste time creating because they're already available on the open marketplace or from an open source. Or here are some components that could be developed by a third-party contractor with whom we already have a working, trusted relationship. So there are some business decisions to be made, and it's not the case that all component development is necessarily done in-house. And if you don't figure out these various approaches to component development, you can end up with a pretty shoddy component development effort, because you haven't thought through not just the technical but also some of the business implications of it. Not enough variability or too much variability, that gets back to basic software engineering 101 about coupling and cohesion and so on. And in fact, I should say that when we do our product line technical probes, a lot of the times the issues and the problems that people are having are not with product lines per se, but they have more to do with the fact that they lack some basic software engineering 101 skills. They're very weak on technical planning. They have no real tool support for what they are attempting to do. They have no real concept of quality attributes in software architecture. So these are things that are not product line specific, but that will come back to haunt you in a product line context because of the multiple product effort that you are setting up and the ripple effect from core assets to products. So if you don't take care of some of these basic software engineering 101 problems before you move into software product lines, you as the product line manager are going to have a difficult time getting a product line launched and then institutionalized. And then we have things like the wrong variation mechanisms or the poor quality of the components that you hand off. The first reference on this slide is to that IESE paper on variability mechanisms. And Jakobsen's book on the reuse-driven software engineering business also has a section on variability mechanisms. The last reference there is to Clemens Siepersky's book on component-based development, Szyperski being the guy who basically wrote the book on this whole idea of a third-party marketplace for components. That was a subset of the software engineering practice areas. The technical management category is now starting to look at the overall product line implementation and interrelationships among the various units that have to come together in a product line effort. The particular subset that we're going to look at deals with the problem of identifying the set of products that will be built as a product line, the scope, the configuration management of a product line as opposed to a single product, and measurement and tracking, how you actually deal with measuring the success or failure, but we hope it's a success, of the product line effort, because sooner or later somebody is going to come looking for numbers that justify the claims you are making about your product line effort. So technical management is all about managing the creation as opposed to actually doing the creation of core assets and products. So this is beyond just the architecture and component development. This is making sure that the supporting practice areas are in place. For example, to make sure that the core assets that you create are effective baseline configured members of the core asset base, and that you have the necessary level of process discipline to create quality core assets and create quality products. So the complete set includes configuration management, the make, buy, mine, commission analysis decision, which is all about where you're going to get the artifacts in your core asset base. Are we going to mine an existing set of products or an existing set of artifacts? Are we going to buy things on the open market? Are we going to commission somebody, a third-party developer, to do it? Or are we going to use a mix and match of all of these approaches? And in fact, most organizations do use a mix and match approach. Measurement and tracking we will look at. Process discipline we have talked about already, and in particular the fact that it's process discipline, not just process definition, but actually following through on the processes that you put in place for your product line. Scoping we will also look at. Technical planning and technical risk management at the product development level or core asset development level deal with the local aspects of creating a particular asset to support a product development effort, or creating a particular product and making sure that it's delivered on schedule and so on. There's a corresponding level of organizational risk management and planning in the organizational management category. And then there is also the category of tool support and coming up with the appropriate set of tools to support a product line effort. And we'll touch on that a bit in the configuration management practice area.